Okay. Hi everyone. Today we'll start Leetcode question number 543, diameter of binary tree. Right. So here, as you can see, so first of all, uh, so what is diameter, right? So diameter is, so let me explain why this diagram. So you have this very simple binary tree, right? So diameter is basically what's the longest path, right? You have to identify the key point, right? The longest path between any two nodes, right? So it is not necessary that it is this root node, right? It's not necessary, right? And then obviously it is, the length is represented by the number of edges, right? So key point is, first is uh, either no or like yes for root node, right? And second, it's not number of nodes, it's number of edges, right? Okay, right. So here also it's mentioned this path may or may not pass right through the root. Now okay, see, if you see this root, right, first of all question come, how is it possible that I'll select only, maybe if let's say there are more nodes there below, right? So if I'll select like this path only or maybe this path only, right? Is it possible that I select in this only? No, because if let's say the height is from this side is 2, right? Here also there will be certain height, right? So it it will be always leaf to leaf, right? Now also like I mentioned, there would be edges only. And now the question comes, how do we traverse, right? How do we go from this to this, then below or to this? So the traversal is kind of follows post order, right? And by post order I mean left, right, and then your whatever value you have, right? So okay, so let me redraw this here. Okay, now the question is, right, uh, okay, we know, right, we have to traverse through first left and right, and you get the value, right? So we'll start with root node, right? So from root node we'll go to left, right? Again we'll go to left, right, because it's a recursion, right? Because it's a recursion. So we'll go on till some base, till a base case, is there, right? So again I'll go to the left, but now there is nothing, right? So now comes the base case, right? So what is base case? If like root or node is equal to null, right? Now if that is null, what should we return? Will return 0, right? So nothing, return 0. Now if you remember, we did this. Now we'll go to right. There is nothing on the right, right? So we'll go back, the base case hits, will return 0. Now is the key part, right? So there are two things, right? First one is we need to return or maintain a variable answer, right? Which will add on the pass. It will say, okay, there are which is basically the maximum number of edges, right? That maximum number of edges are there, right, is 3 or 4 or something, right? So here it's 1 and 2, right? So here is 1 and this is 2. So 2, right? So this we have to maintain. Another thing that when after recursion, even after hitting the base case, right? Because base case hits here, right? Here base case will not hit, right? Here it will continue. So here you have to return something, right? Now what will you return? What do we have to return here, right? First of all, in this simplest case, we have assumed that this is 0, right? We have assumed that this is 0. Let's say there would be some another something, some another node here, some another node here, something, right? So you have to choose only one path here from this or this, right? And how do we choose that? You have to use max, right? So we'll say max of let's say something, right? We'll define this later, what is max of, right? But right, this is like number of edges from this side and number of edges from this side, right? You can't return as it is this term, right? Because you will miss out on this edge. So 1 plus max of this, right? Now what is max of this? So max of basically edges from left and edges from right, right? Whatever edges are coming from this side, whatever edges are coming from this side, right? So max of that, and then 1, because you have to include this edge also, right? Okay, now the question is, we have to also store our answer that till now the right we have seen maybe 2 edges or 3 edges and so on, right? So we have to store that in answer also, or some other variable, right? So this will, so first of all you have to keep on storing in this. So now you have to choose between this stored variable and whatever new value you have, right? And also you have to return the maximum of it, right? What is the maximum number of edges that are there between two edges, right? So again we have to use here max, and what is the max between? So answer, right? And the new value, right? Now what is this new value? So as you can see here, right, this 2 node that is here, right? What is the, so if you remember here, right, 1 2 3, what is the answer of this? The answer is 2. How do you conclude 2? This plus this, right? That is left plus right, right? So max of answer plus left plus right, that's it, right? This is the algo, nothing more than that, right? So you have to, there are only 3-4 points that you have to remember. First is traversal, right? How will you traverse the nodes? What should be the base case, right? And these two values, right? The answer that you need to return, right? And the recursion return, right? If the base case does not hit, what should we return, right? So basically 1 2 3, and these 3 kind of points are the key points. That's it, right? So now let's go to the code and see. So first of all, let's maintain this this answer variable like we mentioned, right? And for recursion, let's make another function, right? Now the base case that I have mentioned, right? If node is equal to run, return 0, right? If node is equal to run, return 0. This is the base case. Otherwise Now this is what? This is your recursion, right? This is this recursion, left, right, and then value, right? So left, otherwise, then it will go to your right node, right? Now this traversal is also done, base case is also done, right? So basically this traversal also done, we have written the base case. Now we have to write this answer, right? We have to update the answer, and like I told you here, it is max of answer and left plus right. So this is also done, right? Now comes the last part. Last part is basically what you need to return if there is, like, if you have surpassed the base case, right? So 1 plus max of either left or right. Okay. That's it. This is the code. We'll call this function and we'll return, what do we want to return? We'll return self plus answer. Let's run it. Okay, now let's run this. All test cases are passed. Let's submit. Yeah, see, now you have to understand what's happening here, right? um, like, you have to understand what's happening here, right? See, like I told you here, right? This is our base case, right? This is our recursion, right? This is our choosing and selecting the answer variable, and then this is our returning if the base case is not passed. Let's do a dry run, right? So let's do very simple, right? So what will happen here? First of all, you run this code, right? You go here, you call the root node. Root node is 1, right? Root node is 1, then it will go node dot left. Node dot left means it will go to 2. If node is equal to none, no, then again node dot left, again. Now we'll check this. If node is equal to none, yes, return 0. So it will return 0. Now it will go to right, right? It will go to right. If node is equal to none, return 0. Yes, it is none, return 0, right? Now remember, we're still at here, we're still at second node, right? So answer is max of answer and left plus right, right? Like I told you before, right? Currently answer is 0. right? And what is left? Left, if you remember, it has returned 0 to the left, right? So left is 0 and right is also returned as 0. So what is max of answer and left plus right? 0, right? So answer is still 0, but what will it return? It will return 1 plus max of left and right. Left and right, it's 0, right is 0, it will return 1, and it is correct, right? It has returned 1, that is this edge, right? Now this is, if you remember, we are only done with this part, right, of for first node. Now it will go to right node, right? Node to node right. So again it'll start the recursion. Is it none? No, right? It will go to left. Is it none? Yes, return 0. Is it none? It will go to right, then it's a return, is it 0? Yes, it will return 0, right? Now what's the answer here, right? Answer is max of answer. That means max of answer is still 0, right? Left plus right. If you remember, left is 1 here, right? And right is 0, right? Why left? No, answer is, so left is also 0 where, right? My bad. Left is also 0, so left is 0 here, right? So yeah, so now we'll go to the answer step, right? What's the answer? Answer is max of answer, right? Answer is still 0, left per right. Left is 0, left is 0, so it will, answer is still 0, right? Now what will it return? It will go to the next step. It will return 1 plus max of left and right. 1 plus max of left and right, right? So it will return 1, which is true, this edge. Now it's the key part. Now for this particular node, this has returned 1, if you remember, this one. And now from right, that is from third, it has also returned 1, right? So it has also returned 1, right? Now answer was 0, right? Answer is still 0, right? What is left to right? Left to right is 1 plus 1, so now answer becomes 2, right? And you have to return 1 plus left, so it's not written. I mean, it will get finished here only, because 1 plus max of left and right, 1 plus like max of left and right, that means 1, right? It will return 2, but it will return 2, but it doesn't matter because we are returning answer, right? And in answer we have stored 2, right? Okay, so this is the try and this is the diameter of your binary tree, Leetcode 543. This is the code. So thank you.